Pre-Socratic natural philosophy. The first philosophical question. In the sun-baked lands of ancient Egypt, a miraculous event occurred each year that both mystified and sustained civilization for millennia. The Nile, lifeblood of the desert kingdom, would swell and burst its banks, bringing forth a bounty of rich black silt that transformed barren sands into fertile fields. For the Egyptians, this annual inundation was nothing short of divine intervention. Myths spoke of the goddess Isis, weeping for her lost Osiris, her tears becoming the life-giving floods. Others saw it as the benevolence of Hapi, the river god, bestowing his blessings upon the land. The people would make offerings, beseeching the gods for a perfect flood, not too high to be destructive, nor too low to leave the fields barren. The very fate of pharaohs hung in the balance, their divine right to rule affirmed or questioned by the whims of the sacred waters. But across the Mediterranean, in the bustling port city of Miletus, a revolutionary thinker dared to challenge these mystical explanations. Thales, a man of commerce and curiosity, had traversed the known world, from the ziggurats of Babylon to the pyramids of Giza. He had absorbed the astronomical knowledge of the Chaldeans and the geometric wisdom of the Egyptians. It was Thales who famously measured the height of the Great Pyramid using only its shadow, demonstrating a mathematical prowess that would echo through the ages. As Thales observed the myriad cultures and their pantheons of gods, a seed of doubt took root in his mind. How could the same natural phenomenon be attributed to so many different deities? There had to be a more universal explanation, one rooted not in the caprices of God, but in the observable world around him. And so, with the audacity that would later earn him the title Father of Western Philosophy, Thales proposed a startling theory. The Nile's flooding, he declared, was caused not by divine tears or godly benevolence, but by the Etesian winds, those strong northerly gusts that swept across the Mediterranean each summer. These winds, he reasoned, pushed against the river's natural flow, causing its waters to back up and spill over its banks. Thales' bold hypothesis sparked an intellectual revolution. No longer content with divine explanations, other thinkers began to propose their own naturalistic theories for the Nile's annual miracle. The quest to unravel this mystery became a catalyst for early rational thought, as captivating as our modern-day search for life on Mars. Nearly 3 centuries later, the great Aristotle found himself still grappling with this enigma, devoting an entire chapter of his Meteorologica to the various theories about the Nile's flooding. But it would take the ambition of Alexander the Great, Aristotle's most famous pupil, to finally uncover the truth. As his armies marched across the known world, Alexander dispatched explorers deep into the heart of Africa, pushing farther south than any Greek had ventured before. It was through these expeditions that the true cause of the Nile's flooding was finally discovered: seasonal rains falling in the distant highlands of Central Africa, far beyond the horizons known to Thales or Aristotle. While Thales' specific theory about the Nile flooding proved incorrect, his revolutionary approach laid the foundation for a new paradigm of thinking called philosophy. The inception of philosophy wasn't about asking different or better questions, as thinkers operating under the myth-making paradigm had equally pondered the same inquiries. Rather, it was about revolutionizing how we understand the world around us. Thales sought naturalistic explanations based on observation and reasoning for phenomena once attributed to the gods. This rational and empirical approach to explain observable phenomena without invoking divine actions was nothing short of radical for his time. The first philosophers, inspired by Thales' method of using reason and observation, sought to answer fundamental questions about the nature of the world, especially, how does the world work? And what is the world made of? About 200 years later, Aristotle referred to thinkers aiming to answer these types of questions as natural philosophers or physicists. Indeed, over a millennium later, Newton identified himself as a natural philosopher as he proposed the governing laws of the universe. From this perspective, the first philosophy born out of these early thinkers is physics. To distinguish these later natural philosophers, the earliest thinkers are called Pre-Socratic natural philosophers. 6 schools of Pre-Socratic philosophy. There are 6 schools of Pre-Socratic natural philosophy we will consider in depth, but first, a brief introduction to each. The Malaysian school, pioneered by Thales, is characterized by monism. Thinkers in this school commonly proposed that the source of all things is a single element, although they differed on what that element was. The second school, exemplified by Empedocles, also identified fundamental things as physical elements, but proposed more than one, believing that a single element alone could not explain the diversity of things we observe. By proposing multiple independent elements, pluralists raised new questions about how these elements might interact. As concrete objects proved insufficient to explain the variety of phenomena in the world, more sophisticated theories moved towards more abstract entities as the fundamental elements of everything, branching into 2 main paths, one leading towards more scientific flavor and the other towards philosophy proper. The scientific path is exemplified by Democritus's atomism and Pythagoras' view of numbers as the essence of everything. Democritus's atomism proposed that all matter is made up of indivisible particles called atoms, a concept that laid the groundwork for modern atomism theory. In his view, even the soul was composed of atoms, smooth, round, and particularly fine ones at that. This materialist stance effectively reduced the mystical to the mechanical, suggesting that consciousness itself was just a dance of particularly nimble atoms. Imagine Democritus, the laughing philosopher, chuckling at the idea that our deepest thoughts and feelings were merely atomic conga lines in our brains. Soul-searching, more like atom-arranging, he might quip, finding humor in the notion that our loftiest spiritual experiences were, at their core, just particles bumping into each other in particularly inspired ways. Meanwhile, the Pythagoreans believed that numbers were the essence of reality, influencing later thinkers like Galileo, who famously stated that the book of nature is written in the language of mathematics. This perspective became crucial in the development of physics, as it allowed scientists to use mathematical equations to describe natural phenomena. Together, these early philosophies shaped the scientific method and provided a framework for understanding the physical world. On the other hand, the philosophical paths of abstraction, more aligned with what we now consider philosophy proper, are found in the works of Heraclitus and Parmenides. Heraclitus proposed that change itself is the essence of things, famously stating, "One cannot step into the same river twice." He perceived the essence of existence as a constant strife between opposing forces, declaring war to be the father of all things. His vision painted a picture of a universe in perpetual turmoil, where creation and destruction, love and hate, life and death are locked in an eternal clash. Such a sight might bring even the stoutest philosopher to tears, for in this relentless conflict lies the very heart of existence. This perspective earned him the nickname the Weeping Philosopher. And finally, we arrive at the doorstep of the Eleatic school, founded by Parmenides, arguably the most revered natural philosopher for his intellectual prowess. Parmenides boldly asserts that everyone got it all wrong. The world as we see it, changing, moving, divided, is mere illusion, and true reality is unchanging, indivisible, and unified. Does it sound strange? Even absurd? Perhaps it's because we're like the lady in Led Zeppelin's Stairway to Heaven, being certain that all that glitters is gold. We often find ourselves guided by the illusions of our senses, in a realm where our physical existence looms large, casting shadows taller than our soul. Parmenides teaches us that ideas gained through our senses lead only to opinion, never true knowledge. To see through the veil of illusion, we must rely on reason. When we grasp the truth, we realize that all is one and one is all, the core of Parmenides' philosophy. With Parmenides, we're elevating the discourse to new intellectual heights, leaping from physics to metaphysics. However, this doesn't render other natural philosophers obsolete. On the contrary, just as human history endlessly churns, the river of ideas flows, forever in motion, never still. These pre-Socratic thinkers, each in their unique way, planted seeds that would grow into mighty trees of thought, branching out across disciplines and centuries. In the realm of philosophy, no idea truly dies. It simply transforms, adapts, and finds new life in unexpected places. As a famous rock singer once said, "The song remains the same, but let's give it a spin." With this introduction, let's begin our journey to the 6 schools of pre-Socratic natural philosophy: monism, pluralism, atomism, Pythagoreanism, Heraclitus's theory of flux, and the Eleatic school. Milesian monism. So, what is the arche, the first principle or matter of the universe? The first theories to consider are those of Thales and his students, Anaximenes and Anaximander. Since these philosophers all lived in Miletus, they are collectively referred to as the Milesian school. Thales proposed that water was the arche, from which all matter in the universe originated. His choice of water was influenced by several compelling observations. Water is readily observable in nature in several forms, demonstrating its transformative nature. Thales recognized that water actively shaped the earth through erosion and other geological processes, carving landscapes and creating habitats. Furthermore, its vital role in sustaining life reinforced his belief in its fundamental importance, as all living organisms depend on water for survival. The fluidity of water may have symbolized adaptability and change, characteristics that Thales likely saw as fundamental to the universe itself. While Thales' idea that water is the fundamental principle of everything might seem naive today, it was groundbreaking for his time, when people often attributed the creation of the world to gods. Imagine living in an era where every natural phenomenon, like storms or earthquakes, was explained by divine forces. Thales dared to think differently. He believed that instead of relying on the whims of gods, there could be a single principle that explains everything around us. His ambition to find this first principle was as bold as what some modern physicists strive for today with their quest for a theory of everything, TOE, that can unify all the laws of physics. Of course, Thales' water theory, revolutionary as it was, had its limitations. If everything comes from water, how do we explain fire or rocks? These questions must have nagged at Thales' student, Anaximander, as he pondered the nature of the universe. Imagine Anaximander walking along the shores of Miletus, observing the interplay of water, earth, and air, and thinking, there must be something more fundamental than water, something we can't see or touch, but from which everything else emerges. This line of thinking led Anaximander to propose a concept so abstract it almost defies imagination: the apeiron. The apeiron, meaning boundless or indefinite, was Anaximander's candidate for the arche, a primordial substance both eternal and ageless. Unlike water, fire, or any tangible element, the apeiron encompassed all opposites, hot and cold, wet and dry. It was a cosmic wellspring from which all things in the universe emerged and to which they would eventually return. Anaximander's concept of the apeiron, the boundless and indefinite, at first glance seems like a theory of everything pushed so far that it becomes a theory of nothing. Yet, on deeper reflection, it bears intriguing parallels to our modern understanding of matter in quantum mechanics. Just as the apeiron is an abstract, indefinable principle from which all tangible things emerge, quantum physics reveals matter at its most fundamental level to be a puzzling interplay of particles and waves, probabilities and potentials. The quantum vacuum, often described as a sea of virtual particles constantly popping in and out of existence, echoes the apeiron's nature as a state of pure potential. Moreover, the apeiron's ability to encompass opposites mirrors the wave-particle duality in quantum mechanics. This ancient concept, in its abstraction and its attempt to grasp the fundamental nature of reality, shares a certain esoteric quality with our current scientific quest to understand the fabric of the universe. Both the apeiron and quantum mechanics challenge our intuitive understanding of the world, reminding us that the deepest truths of nature often lie beyond our everyday perceptions. While Anaximander's concept of the apeiron was groundbreaking in its abstraction, it faced a significant challenge. Its very indefinability made it difficult to connect to the observable world. How could something so abstract and unknowable give rise to the tangible reality we experience? This question likely troubled Anaximenes, Anaximander's student, who sought to bridge the gap between the abstract and the concrete. Anaximenes recognized the need for a fundamental substance that was both universal and observable. He found his answer in air, an element that seemed to permeate everything, yet could transform into other substances. Unlike the intangible apeiron, air provided a more relatable and observable basis for explaining the diversity of matter in the world. By proposing air as the arche, Anaximenes retained the core idea of a single primary substance but grounded it in the physical world. This shift marked a return to a more tangible element, similar to Thales' water, but with a more developed theory of transformation. Anaximenes argued that air, through processes of rarefication and condensation, could account for all other forms of matter, from the ethereal, fire, to the solid, earth. The Malaysian philosophers, with their monistic views of arche, made groundbreaking strides in natural philosophy. However, their theories faced significant challenges in explaining the diversity and change observed in the world. If everything is fundamentally one substance, how can we account for the apparent multiplicity and transformations we see around us? These difficulties led some subsequent thinkers to propose pluralism as an alternative framework, positing that reality consists of multiple fundamental substances or principles rather than a single arche. Pluralism. Pluralism posits that the fundamental elements of the world are multiple rather than singular. This view, championed by thinkers like Empedocles and Anaxagoras, offered a more intuitive explanation for the diversity and change observed in nature compared to monistic theories. Empedocles' 4 elements. All right, buckle up, philosophy fans. We're about to dive into the wild and wacky world of Empedocles, the ancient Greek thinker who was part philosopher, part mystic, and 100% showman. Picture this. It's the 5th century BCE in Acragas, Sicily. The streets are bustling, and suddenly the crowd parts. Who's that strutting down the road like he owns the place? It's Empedocles, decked out in a purple robe that would make Prince jealous, a golden girdle that puts WWE champions to shame, bronze sandal that are probably terrible for his arches, and a Delphic laurel wreath perched atop his head. This guy isn't just making a fashion statement. He's declaring himself a living, breathing god. But Empedocles wasn't just about the bling. Oh no, this guy had some serious mind-bending ideas. Let's start with his theory of evolution. And no, we're not talking about Darwin here. Empedocles imagined a world where body parts just popped out of the ground like daisies. Heads without bodies, arms without shoulders, you name it. These parts then played a cosmic game of mix and match, creating all sorts of wild creatures. Most of these combos were total flops. Imagine a foot with ears. But the ones that worked? Voila! That's how we got the animals we see today. It's like Mother Nature was playing a giant game of Mr. Potato Head. Now, hold on to your togas, because we're about to get elemental. Empedocles said everything, and he meant everything, was made up of 4 elements: earth, air, fire, and water. He called these the roots of all matter. But wait, there's more. These elements weren't just chilling there. They were caught in a cosmic tug-of-war between 2 forces, love and strife. No, not your average rom-com drama. We're talking universal forces here. Love was all about bringing things together, making the elements mingle and form new stuff. Strife, on the other hand, was the ultimate party pooper, always trying to tear things apart. Empedocles saw the whole universe as this eternal dance between love and strife. When love was winning, everything mixed into this perfect sphere he called the spheros. Imagine the ultimate cosmic smoothie. But when strife took over, it was like hitting the cosmic blender's pulse button and everything separated. Now, was this theory perfect? Well, not exactly. It was a bit too simple to explain all the complexity we see in the world. And let's be honest, love and strife sounds more like a soap opera than a scientific theory. But give the guy some credit. He was trying to explain the entire universe with just 4 elements and 2 forces. That's like trying to write a symphony with a kazoo and a pair of spoons. Despite their flaws, Empedocles' ideas were a big hit. Aristotle, the rock star of ancient philosophy, took this 4-element theory and ran with it, adding his own twist. And in medicine, doctors started seeing the human body as a microcosm of the universe, with 4 humors corresponding to the 4 elements. Feeling under the weather? Your humors were probably out of whack. But the grand finale of Empedocles' life might just be the most epic. Legend has it that to prove he was truly a god, Empedocles decided to take a swan dive into Mount Etna's fiery crater. His plan was to vanish without a trace, leaving everyone to believe he had ascended to godhood. Spoiler alert, it didn't quite work out that way. The story goes that the volcano, clearly not impressed with his divine aspirations, spat out one of his bronze sandals. Talk about a hot foot. So there you have it. Empedocles, the man who lived large, thought big, and went out with a bang. Anaxagoras' noose. It's ancient Athens, 5th century BCE, the bustling heart of philosophy and drama. The agora is buzzing with excitement as a crowd gathers around a man with wild eyes and wilder ideas. This isn't your average street performer. It's Anaxagoras, the mind-bending philosopher from Ionia. In one corner, you've got Euripides, scribbling famously in his notebook, probably cooking up his next tragic masterpiece. In another, there's Pericles, the smooth-talking politician, hanging on every word. And at the center of it all, Anaxagoras, dropping intellectual bombs like they're going out of style. But hold on to your togas, folks, because Anaxagoras is about to shake things up. He's not just teaching philosophy. He's lighting a bonfire under the seat of conventional wisdom when he declares, "That big, shiny thing in the sky you've been worshiping? Yeah, it's not Apollo's chariot. It's a massive ball of fire." You can almost hear the collective gasp of the Athenians. But wait, there's more. Anaxagoras points to the moon and drops another mind-blower. See that? It's not glowing on its own. It's just reflecting the sun's light. It's like he's pulled the script for a sci-fi blockbuster straight out of thin air. Now, you'd think the Athenians would be thrilled with these revolutionary ideas. Critical thinking at its finest, right? Wrong. To them, this isn't enlightenment. It's blasphemy of the highest order. The crowd that was hanging on his every word, they're now calling for his head. It's exile or execution for our celestial truth-teller. But don't worry, folks. Anaxagoras may have left the building, but his ideas, they're here to stay, ready to blow the minds of generations to come. At the heart of Anaxagoras' philosophy was his mind-bending idea of everything in everything. Imagine this. Every substance in the universe contains a tiny bit of everything else. This revolutionary concept allowed Anaxagoras to explain the dazzling diversity and complexity of nature in a way that far surpassed the simpler 4-element theory proposed by Empedocles. For example, consider that apple you're munching. According to Anaxagoras, it's not just apple through and through. It contains microscopic traces of gold, iron, and even stardust. These minuscule particles of other substances are present, just waiting for the right conditions to manifest. Similarly, imagine a little baby born bald. When he grows a full head of hair a few months later, Anaxagoras would argue that those hair particles were there all along, mixed in with his scalp. They're like microscopic chia pets, just waiting for their moment to sprout. This concept explains how things can seemingly come into being without violating the principle that nothing comes from nothing. The key question for Anaxagoras was how things know when to transform, like a bald head suddenly growing hair. This challenge of explaining how diverse elements interact and change was common to pluralist philosophers. While Empedocles relied on love and strife to explain changes and suggested that life arose randomly, Anaxagoras introduced a more sophisticated mechanism. Nous, in Anaxagoras' vision, is an infinite intelligent force that orchestrates the cosmos like a master conductor. It provides a rational mechanism for order and structure in the universe, offering a more sophisticated explanation for the organization and motion of matter compared to earlier theories. Anaxagoras introduced mind as the ultimate force that brings clarity to chaos, arguing that, just as our minds sort through confusion, an active mind, nous, governs the cosmos. To arrive at this notion, Anaxagoras drew on the human analogy, applying the microcosm-macrocosm principle. He reasoned that in the human sphere, when things are in confusion, it's the activity of mind that sets them in order. The human mind distinguishes one thing from another and puts everything in its proper place. Therefore, in the cosmos, there must be a mind active in nature that orders and controls in a similar way. However, this concept of a cosmic mind governing the universe wasn't without its critics. Aristotle, while appreciating Anaxagoras' introduction of nous as an ordering principle, felt it attributed too much divine intelligence to nature. Nevertheless, Anaxagoras' idea of mind likely inspired Aristotle's notion of a final cause or telos, the idea that there's a purpose within nature and that all motion can be explained by the striving of each object to fulfill that purpose. In essence, Anaxagoras' concept of nous represented a significant step in philosophical thought, introducing the idea of a controlling rationality within nature that acts as the source of all motion. This laid the groundwork for future explorations into the nature of causality and purpose in the universe. Atomism. Atomists are the new kids on the philosophical block, ready to shake things up with some seriously small ideas. Atomism proposed a universe composed solely of atoms and void, a theory developed by Leucippus and further elaborated by his student Democritus. Not much is known of Leucippus, possibly once a student of the Eleatic school founded by Parmenides, but he rejected its view on the impossibility of motion. Democritus, born in Abdera, mentions that he was 40 years younger than Anaxagoras, the philosopher who proposed the nous, the cosmic mind. Atomists aimed to refute both Anaxagoras' nous and the Eleatic school, which asserted that only existence is possible and non-existence impossible, denying the reality of change. They were motivated to offer a worldview that corresponded to our sense perception, where change and motion are possible. To counter the Eleatic teaching of no motion and no change, the atomists proposed a universe of atoms. These atoms, varying in shape and size, are the ultimate building blocks of everything you see, feel, and even think. They're in constant motion, colliding and regrouping in an eternal cosmic dance. Change and movements are just this ceaseless motion of atoms, accounting for the ever-changing nature of our world, from the growth of a flower to the erosion of a mountain. Yes, even your thoughts are just atoms doing a complicated tango in your brain. The atomists also rejected nous, the notion of intelligent design governing the universe. They asserted that all reality, both physical and mental, can be traced back to these tiny particles in motion. There is no intelligent mind orchestrating events. Even our souls or minds are composed of fine, spherical atoms that cause perception and thought through their motions within the body. Thus, mental processes can be explained purely by mechanical interactions and rearrangements of atoms. When we die, Our souls leave the body and recombine into something else. There is no enduring soul of a person. It's a bit like cosmic recycling. Today's philosopher might be tomorrow's turnip. Just as humans do not possess minds or souls independent of their bodies, physical properties exist only through atomic interactions. Democritus famously stated, "By convention sweet and by convention bitter, by convention hot and by convention cold, by convention color, in truth, atoms and void." This indicates that sensory qualities are subjective results of atomic interactions rather than inherent properties. In other words, that apple you're eating isn't inherently sweet, it's just playing a trick on your taste buds with its clever arrangement of atoms. This materialistic worldview may have contributed to Democritus's reputation as the laughing philosopher. Perhaps he found humor in the idea that everything from mountains to mustaches was made up of these invisible little atoms. With no fear of an afterlife or immaterial soul weighing him down, he could truly enjoy living. After all, why worry about the afterlife when this life is just one big atomic party? The atomists pioneered a thoroughly materialistic, mechanistic, and reductionist philosophy, one that resonates with modern scientific thought. However, they faced significant challenges. One is the lack of logical rigor. Atomists identified change and movement as the perpetual dance of atoms in the void. Void, that is nothingness. Atomists posited the existence of void without any evidence. Indeed, even modern science cannot prove the existence of void in the absolute sense. On the other hand, void, that is nothingness, is what the Eleatic school had proved to be impossible. It's like insisting on the existence of a cookie jar that is permanently empty to a philosopher who proved that all cookie jars must contain cookies, since a cookie jar without cookies is not properly called a cookie jar. Aristotle offers a different criticism. He believed that atomists threw away the baby with the bathwater as well. Aristotle argued that the atomists, in their zealous attempt to remove all anthropomorphic elements from their explanation of nature, had actually removed too much. They left no room for the apparent purposefulness we observe in natural processes, like the growth and development of living things. If everything is just atoms moving randomly in a void, Aristotle asked, how do we account for the fact that puppies consistently grow into dogs, not cats or foxes? This predictable development suggests that there is some kind of guiding principle or inherent purpose in the cosmos, and atomism cannot explain this cosmic purpose with the simple theory of atoms dancing in the void. So there you have it, atomism in all its mind-bending glory, along with its most significant critique. A theory that dared to explain everything from the cosmos to consciousness with nothing but tiny particles and empty space, yet struggled to account for the orderly development of puppies into dogs. Pythagorean school. The pre-Socratic philosophers made a fascinating leap from tangible elements to abstract concepts, evolving from the simplicity of water to the complexity of atoms and the rational mind of Nous. It's like they were playing a cosmic game of Jenga, removing solid blocks and replacing them with increasingly abstract ideas. After all, when you're trying to explain everything, sticking to what you can see leaves you with a philosophy as shallow as a puddle. Enter the Pythagoreans, who took abstraction to new heights, or should we say new angles. Led by the triangle-loving Pythagoras, the most powerful ideas are the ones you can't see. But before we explore his contribution to philosophy, let's first clear the air with one command that Pythagoras is well known for. Don't eat beans. This intriguing directive is left in fragmentary form, without any explanation as to why. Naturally, scholars have tried to decode what he might have meant by this peculiar dictum. One popular interpretation suggests a practical reason for avoiding beans. They can cause flatulence. Imagine trying to contemplate the mysteries of the universe in a room full of, well, let's just say, atmospheric disturbances. However, a more philosophical reason can also be proposed, relating to the status of the soul. Opposing the atomist view that the soul dies with the death of a person, Pythagoras believed in the immortality of the soul and its reincarnation. He posited that the soul, psyche, is immortal and undergoes a cycle of reincarnation or transmigration into different living beings after death. Like many of his contemporaries, he thought beans contained the souls of the dead. Thus, eating them was considered sacrilegious. Now that we've cleared the air on not eating beans, let's move on to his profound philosophy. The Pythagoreans believed that what constitutes the universe is not merely physical things, but rather numbers themselves. While we may not fully understand their rationale for this belief, it can be appreciated as numbers are abstract and generalizable concepts. For instance, if we were to don the metaphorical hat of Pythagoras, we could observe that some entities in our world are uniquely singular, like the sun or the moon. From this observation, one could generalize the concept of one. Next, we notice that some things always come in pairs, like man and woman, or husband and wife. From this pairing, we derive the number 2. For 3, we can think about elements requiring exactly 3 components. Triangles need 3 sides, there are 3 states of matter, solid, liquid, gas, and we live in 3 dimensions, length, width, height. By observing these patterns, they concluded that numbers were the true building blocks of reality. It's like they were playing a cosmic game of I Spy and kept finding numbers everywhere. Not only did Pythagoreans believe that the world is made up of numbers, but they also posited that the universe operates based on relationships among these numbers. Consider the relationship among 3, 4, and 5. According to their famous theorem, the sum of the squares of 3 and 4 equals the square of 5. It's not just a mathematical party trick. To the Pythagoreans, it was like catching the universe with its pants down, revealing its numerical underpinnings. They saw this triangle of truth as proof that the cosmos was more ordered than a librarian's sock drawer. By investigating these relationships among numbers, Pythagoreans saw the universe as a grand symphony, with mathematical relationships as its musical score. This high level of abstraction deeply influenced Plato. It is said that the phrase, "Let no one ignorant of geometry enter," was inscribed over the entrance to Plato's academy in ancient Athens. Plato saw that logical reasoning in mathematics has the power to draw the soul towards truth, and elevate the mind from the world of visible, changeable things to the world of immaterial, eternal beings. The famous inscription captures Plato's conviction that mastering logic was a crucial prerequisite for engaging in the highest philosophical pursuits at his academy. Fast forward a couple of millennia, and modern science seems to be giving old Pythagoras a fist bump from the future. As physics has evolved, it's become more mathematically inclined than a bookkeeper on tax day. Newton's laws of motion? They're basically numbers doing the cha-cha. And don't even get me started on quantum mechanics. It's like numbers decided to throw a rave party in the subatomic realm. Take the Schrödinger equation, for instance. It's not just a fancy name for a cat's existential crisis. It's a mathematical beast that describes how particles behave when we're not looking. With Pythagoras and later Plato, philosophers have been pondering the ontological status of numbers. Do numbers really exist? Or are they just convenient fictions like the idea that kale tastes good? As the language of physics has become increasingly mathematical, a new argument for mathematical realism has emerged, the indispensability argument. This argument asserts that we should believe in the existence of all entities crucial to our scientific theories. Since mathematical entities like numbers, sets, and functions are indispensable to these theories, the argument concludes that we should believe in their existence too. It's as if the argument is saying, if you're on board with quarks and black holes, you've got to roll out the red carpet for numbers and sets too. They're the VIPs of the scientific theory party. The indispensability argument challenges the practice of accepting theoretical physical entities while rejecting mathematical ones, labeling this inconsistency as metaphysical apartheid. It accuses those who do this of intellectual dishonesty and maintaining an unjustifiable double standard in their ontological commitments. In this way, the indispensability argument urges us to be consistent. If you're inviting science to the reality party, you'd better make sure math gets an invitation too. After all, can you really have a physics bash without the mathematical guests who make it all possible? So, Was Pythagoras right? Is the universe secretly a giant abacus? While we can't say for sure, modern physics certainly seems to be giving his ideas some serious street cred. Whether numbers are the fabric of reality or just really good descriptors, one thing's for sure. Pythagoras' legacy is still adding up thousands of years later. Heraclitus' permanent flux theory. Alright, folks, we've been on quite a journey through the wild world of pre-Socratic natural philosophy. We've seen thinkers trying to crack the code of the universe, searching for that elusive arche, the fundamental stuff that makes up our world. From the Milesians with their simple elements to the mind-bending numbers of Pythagoras, we've watched these ancient brainiacs get more and more sophisticated in their quest. But now, ladies and gentlemen, we've arrived at the main event, the philosophical heavyweight championship of the pre-Socratic world. In one corner, we have Heraclitus, the master of flux, proclaiming that change itself is the only constant. And in the other corner, we have Parmenides, the immovable object, declaring that nothing ever really changes at all. Talk about a clash of the titans. Let's start with our first contender, Heraclitus. Heraclitus was from Ephesus in Ionia, modern-day Turkey. While various philosophical schools sought to identify what truly exists in this world, Heraclitus rejected any notion of permanence in the universe. The only truth that would never change is change itself. This view of Heraclitus is called the theory of permanent flux. This idea is succinctly expressed in his doctrine: you cannot step into the same river twice. At first glance, the saying doesn't sound quite right, as it may seem like we can step into the same river. However, upon closer examination, we indeed cannot. Rivers are characterized by their flowing nature. Water in a river is always moving downstream. When you step into a river, the water that touches your feet is immediately carried away, replaced by new water flowing from upstream. Thus, the specific molecules of water that touched your feet the first time are not the same ones touching them if you step in again. What is not the same is not just the water in the river, but us as well. Like the water in the river that moves with the flow, our existence is bound to time. So, just like the water, we are always moving forward through time, and with each passing moment, we become slightly different from our past selves. Our bodies are constantly undergoing biological processes, cells dying and regenerating. Every moment brings new experiences, information, and stimuli that impact our mental and emotional states. What you experience, learn, and feel in the present moment influences your thoughts and feelings, making you slightly different from who you were a moment ago. Just as the river's waters are always moving and changing, so too are we always undergoing subtle changes. This results in neither we nor the river remaining the same from one moment to the next. When we extend this line of reasoning, nothing in the world can escape the force of change. Everything is constant change, Pantareia. This is the theory of permanent flux. There is nothing in the world that is permanent. Things are constantly changing and never the same. According to Heraclitus, constant change arises due to the dual existence of reality, like the two sides of a coin, day and night, life and death, health and sickness, hot and cold, light and dark, creation and destruction, love and hate. These opposites depend on each other and arise from one another. Existence is like a seesaw on a playground. For it to function properly, we need two opposing forces, one child on each end pulling in opposite directions. The world is composed of opposites. Conflict and tension between these opposites are necessary for harmony and balance. Some might think that balance means no movement at all, like a seesaw where opposite forces cancel each other out. But for Heraclitus, that is not harmony or balance at all. In a state that lacks any struggle, the seesaw would just be a boring plank on the ground. Harmony is achieved through the tension of opposites, he argued, not their absence. Just as a seesaw needs up and down movement to function properly, the world consists of opposites that are completely interconnected and interdependent. This worldview sounds pretty intense, right? Constant struggle as the ideal state of harmony? In other words, Existence boils down to fight after fight after fight. No wonder he was called the weeping philosopher. So how was Heraclitus received? Aristotle was quite caustic toward him. Imagine Aristotle, a man who had just finished writing a logic book, encountering Heraclitus' ideas. He found Heraclitus' thoughts contradictory and called him someone who could not reason correctly. For Aristotle, contradictions were a big no-no. Heraclitus' relativistic maxims, like the way up and the way down are one and the same, inevitably influenced the next generation of philosophers known as sophists. Indeed, Aristotle labeled Heraclitus as their father, which is far from being complimentary. For millennia, Heraclitus' theory of permanent change was about as popular as a vegetarian at a barbecue contest. The philosophical heavyweights Plato and Aristotle had given it the old 1-2 punch, and it lay forgotten like last year's New Year's resolutions. But then along came Friedrich Nietzsche in the 19th century, intellectual rebel extraordinaire who decided to dust off Heraclitus' ideas and give them a new spin. Eleatic School. And our journey through pre-Socratic natural philosophy makes its final stop at the doors of the Eleatic School, founded in Ilia, Italy, by Parmenides. The intellectual prowess of Parmenides was so legendary that even Plato, the master storyteller of philosophy, couldn't resist his allure. In a stroke of dramatic genius, Plato cast Parmenides as the ultimate philosophical heavyweight in his dialogue, aptly titled Parmenides. In this dialogue, Plato flips the script on Socrates. Our usual wise old man, known for his sharp wit and relentless questioning, finds himself as a young and eager philosopher encountering the legendary Parmenides. It's like watching a philosophical Freaky Friday, but with togas instead of body swapping. The revered Parmenides breaks silence, asking, "Tell me, young Socrates, what do you believe about the nature of reality?" Socrates excitedly shares his theory of forms, but Parmenides isn't easily swayed. He challenges Socrates with piercing questions, dissecting his arguments like a skilled surgeon, or perhaps a philosophical Gordon Ramsay critiquing half-baked ideas. If these forms exist in their own realm, he asks, how can we ever truly know them? Can something that is perfect ever interact with our flawed world? The young Socrates stumbles. Given that even Socrates bowed to Parmenides, we can expect some awesome theories, and oh boy did he deliver. First, we learn that all the previous natural philosophers were mistaken. The idea that existence is many, as proposed by Empedocles, the atomists, and the Pythagoreans, wrong. Heraclitus' theory of perpetual change in motion, also wrong. It's like Parmenides is hosting a philosophical roast, and everyone's invited. Parmenides' revolutionary idea for true reality? Just 3 words. What is, is. True reality, he argued, consists only of what exists or has existence. In other words, it's impossible for what is to not be. Talking about something that doesn't exist? According to Parmenides, that's a philosophical no-go. Consider the statement, Santa Claus does not exist. We typically take this as a true statement in our reality, but not for Parmenides. His reasoning goes like this. If Santa Claus exists, then saying he doesn't is false. If Santa doesn't exist, we're first positing his existence to talk about him, then denying it. A classical case of philosophical double talk. It's like inviting someone to a party and then slamming the door in their face when they arrive. Thus, Parmenides concludes that we can only discuss things that exist. It's impossible to talk about something that does not exist. After establishing that what is, that existence is the only possibility and non-existence is impossible, Parmenides explores the nature of being or existence more deeply. Existence must be one. If existence were plural, there would have to be gaps or separations within being. These gaps would imply the presence of non-being. But since non-being is impossible, gaps cannot exist. Thus, being must be one. Existence must be unchanging. Change would imply something coming into or out of being, which involves non-being. Since non-being is impossible, change itself must be impossible. So much for those New Year's resolutions. Existence must be motionless. For an object to move, it must transition from being, what is, to non-being, what is not. Since non-being is impossible, motion cannot occur either. From these arguments, Parmenides concludes that being must be a singular, unchanging, unmoving entity, like the ultimate philosophical rock that refuses to budge. In fact, if Led Zeppelin had written a song about Parmenides' concept of being, it might have been called Be a Rock, Don't Roll. Zeno, Parmenides' top student, crafted paradoxes to challenge our understanding of motion and change. Let's consider two of his famous paradoxes. First, the Achilles and the tortoise paradox. Imagine a race between swift Achilles and a slow tortoise. The tortoise gets a head start. Zeno argues that Achilles can never catch up. Why? Because each time Achilles reaches where the tortoise was, the tortoise had moved a bit further. This keeps happening, creating an infinite series of smaller and smaller distances. Zeno concludes that Achilles can never overtake the tortoise, even though the gap between them gets tinier and tinier. Now, the arrow paradox. Picture an arrow in flight. Zeno claims this motion is an illusion. He argues that at any single instant, the arrow occupies a space equal to its length and is therefore motionless. Since time is made up of these instants, and the arrow is at rest in each one, Zeno concludes the arrow must be motionless throughout its entire flight. It's like trying to create motion from a series of still photographs. Or, to put it in modern terms, Zeno's paradox suggests that if we break down motion into its smallest parts, we find nothing moving at all, as if Zeno could pluck a flying arrow out of the air with the same ease as Neo catching bullets in the Matrix, both revealing the illusory nature of motion in their respective realities. In the Iliadic school, we find ourselves in a world reminiscent of the Matrix. Clearly, our perceptions tell us that motion and change exist, but Parmenides' logic shows that this is an illusion. Like the oracle in the Matrix, Parmenides reveals that we are guided by the way of opinion, doxa, a path of perception and appearance. Our senses perceive a world of change, motion, plurality, and becoming. However, Parmenides regarded this as merely untrustworthy opinion or illusion, not reflecting true reality. Parmenides beckons us towards the way of truth, aletheia, the path of reason, logic, and what truly is. While Neo faced the stark choice between the blue and red pill, we might find a more melodious metaphor in Led Zeppelin's Stairway to Heaven. As the lyrics remind us, yes, there are two paths you can go by, but in the long run, there is still time to change the road you're on. This poetic crossroads mirrors Parmenides' distinction between the way of truth and the way of opinion. Like cosmic wayfarers, we must discern between the illusory world of appearances and the unchanging reality that lies beyond, choosing whether to remain in the comfortable shadows of our perceptions or to ascend the challenging stairway to philosophical enlightenment. Aftermath. So what happened? The Iliadic school's promotion of reason over the senses and their long-lasting effects on the methods of philosophy give them a strong claim to being among the most powerful pre-Socratic philosophical movements. In philosophy, logic reigned supreme, and the Iliadics were its early champions. Zeno's paradoxes excited the minds of intellectuals for millennia. It seems so obvious that Achilles should overtake the tortoise and that flying arrows are in motion, yet the logic of the arguments appears sound. This contradiction puzzled philosophers and mathematicians for over 2 millennia. The resolution to this mind-bending puzzle only came with the development of calculus in the 17th century, a full 2,500 years after Zeno first posed his paradox. It turns out that while Achilles does indeed need to cover an infinite number of distances, these distances form a convergent series, meaning their sum is finite. In other words, Achilles can cover all these infinite points in a finite time, finally catching that pesky tortoise.